So one thing we can do, one thing we can look at with a vector is a construction called a unit vector, where a unit vector takes some vector v, and the word vector is going to hit what's the word, verbal satiation soon. It's going to lose all meaning for me and all of you because I keep having to say vector. But basically what this does is it says, okay, let's find another vector that goes in the same direction but only has magnitude 1, where if we want to get that, what we do is we take our original and divide it by its magnitude. We rescale it down by its own length. Makes sense that that should work. And to see this in practice, we have another example here. For this example, we want to find the unit vector in the same direction as v equals negative 3i plus 4j, and then verify that it actually is a unit vector. That is, verify that its magnitude is 1. So, the first thing we need here is the magnitude of v. We need to find how long this vector is, in a sense. Where to do that? Same thing it's always been. We just take the square root of its components squared. Negative 3 squared plus 4 squared, where that is going to end up being one of those very friendly values we see, 9 plus 16, square root of that will leave 5. So our magnitude here is 5, and if we want to get the unit vector from that, we want to get v over its magnitude, we'll just take our value v, our vector v, negative 3i plus 4j as vectors, and divide out 5, which is the same as multiplying by the constant 1/5, really. So we'll end up with negative 3/5 I plus 4/5 j. And if we want to be sure that this actually is a unit vector, that this actually does have magnitude 1, we can check with some really funky looking notation, because we don't unfortunately have a shorthand for a unit vector at the moment, or at least I didn't copy one down. But we can take the magnitude of our unit vector, which looks kind of dumb like that, admittedly, but really what we're doing here is just taking the square root of those components squared. So we'll have negative 3/5 squared plus 4/5 squared, which is going to end up being 9 over 25 plus 16 over 25. And like so many things in this class, this just happens to be a very long-winded way of writing 1, because, well, just to be sure, this is the square root of 25 over itself, or as most people would prefer to say, 1. And the last thing we're going to do in this section before going on to talk about those dot products that I've mentioned is, well, finally talk about a little bit of trigonometry, because what would this be doing in our chapter on additional topics in trig if I never talked about this in terms of magnitude and direction?